The point of contact between the cartilage and the subchondral bone can sometimes be hard to identify. The appropriate inflection point in the force versus displacement curve indicates the point of contact of the needle tip with the subchondral bone. However, this change in force is not always easy to locate. I will show you some examples of atypical curves that can be used as a guide to identify the correct point of contact with the subchondral bone. This is an example of a normal thickness curve where there's a clear point of inflection that is a steep increase of the absolute value of the force. This corresponds to the position of contact with the subchondral bone. If using the same needle for the entire articular surface, the needle tip is likely to become blunt over time. When this happens, it may not be sharp enough to pierce the cartilage at point of contact. This results in an increase in force followed by a quick decrease when the needle eventually perforates the cartilage. This produces an artifact shown in the region with the red circle and should not be included in the analysis. For this type of curve, the correct point of contact with bone corresponds to the inflection point associated with the sharp increase in the absolute value of the force with no immediate decrease. When the bone is very porous, it is common to observe a force versus displacement curve showing a steep increase in force, followed by a series of increases and decreases. For this type of curve, the correct point of contact with subchondral bone corresponds to the inflection point associated with the first sharp increase in the force value, circled in green. The following wavering is associated with the perforation of pores in the bone shown in the red region and should be excluded from the analysis. Calcified cartilage is present between the hyaline cartilage and the subchondral bone. Its interface with the non-calcified cartilage is called the tide mark, and it is usually stiffer than non-calcified cartilage but less stiffer than bone. When this region is thick enough, the force versus displacement curve will show an increase in force as the needle enters this zone. In this case, there will be 2 points of inflection. The first increase in force can be interpreted as the location of the tide mark, which is circled in red, and should be excluded from the analysis. The second inflection point, circled in green, represents the correct position of the subchondral bone as there is a steeper increase in the absolute value of the force. The vertical force is also recorded when the needle returns to its original position. In these examples, this corresponds to the region defined by a rapid decrease in force, that is, towards 0 newtons. Here is an example of the force that does not go back to 0 newtons, likely due to the needle slipping on the edge of a sample and thus never reaching the subchondral bone. This is likely due to either a blunted needle tip, a position too close to the edge of a sample, or a surface angle too steep. Generally, the normal indentation curves with an angle greater than 60 degrees from the z-axis should not be included in the analysis.